All right, so let's get into this. Again, watch any of the intros and everything on your own. So in this lesson, we will learn to compare polynomial arithmetic with integer arithmetic and write polynomial equivalency. So if these words don't make that much sense to you, just know polynomials. That's that thing where'd my pen go? There it is. Okay, cool. We're gonna do these like x squared plus x, anything with like this x on the bottom, and sometimes it can have a exponent, sometimes it doesn't. Sometimes it can just be a number. The reason why it can be a number is this is basically an exponent with a zero. An exponent with zero, or an exponent, a variable with zero as an exponent is just a one. So it'd be 3 times 1. So it just shows up as 3. So let's get into this. And integer just means a number. It could be a positive number, it could be a negative number. And arithmetic just means like adding and subtracting. So that's why integers can be positive or negative. And writing equivalent forms. So writing equivalent forms is just another way of saying stuff that's the same, you know? Anything that's the same. All right, so let's get into this one. We have a few slides going. So talking about this. So an equivalent form would be we would have to add all of these together and do all this multiplication. So this one actually has quite a bit of work on it. So what we would do first is we want to distribute this negative, right? So we get this 3x squared plus 9x plus 6, right? Then we have to distribute this negative. So we get this negative 8x squared, then minus 3x minus 10. One thing I want you guys to kind of learn is I'm sure you guys have seen this before when you have two binomials. Binomials just means it has two terms. Binomials means we're going to have two terms like this. When we're multiplying it, you guys might have learned it by FOIL. I'm going to teach you guys how to use it multiplying with the box method. So FOIL, first outer, so we distribute the 2x, then we're going to distribute the 4 to both of them. So this is known as FOIL. It stands for first outer inner last. A lot of people do it this way because it's like, oh, it's just distributive property, just we're doing it for two things. I'm going to teach you guys how to FOIL using the box method. So the way you FOIL using the box method is we have this box. We put our 2x here and our 4 here. And from here, what we're going to do is we're going to write our 3x here and our negative here, right? So from here, we're going to multiply these two together. This 2x times 3x. So can anyone tell me what 2x times 3x is? You guys can type it in the chat or 6x. Close. It's actually 6x squared. But yeah, because x times x is x squared. I know that's hard to type it in the chat. The way you would type it in is x, this little caret sign, and a 2. Oh, yeah. I guess you could also type in the word squared too. So that's what we get here. What do you guys think is going to go in this box right here? So this box is going to be what this times this. So 4 times 3x. So what do you guys think 4 times 3x is? 12x, yes. So that's what we're doing here essentially. We're just completing the square, we're doing length times width. This is also known as the area method. So if I do this, I get this negative 14x, and I get this negative 28x, negative 28. There's no x's. So this is FOIL. I distribute here, I get this 6x squared in the first box. I distribute over here, and I get this negative 14. So I'm basically just foiling it. Is that going to be your answers from now on, Nelson? Just what he said. All right, that seemed unnecessary. So what we're doing here is distributing there. That gives us this box. Distributing here, that's going to give us this box over here. And when we distribute this way, that gives us this box. So this is a good way to kind of know how to multiply these out together. And if you think about it, that's how we normally do multiplication. We do length times width. 3, 2, that's going to be a 6. Length times width. That's how we find the area. So that's why this is called the area method. So now that I've done this box, I'm going to do everything here. So it's going to be positive 6x squared plus 12x minus 14x minus 28. Does that make sense how I did this, guys? How I came up with these numbers? Yes, no, maybe? Cool. So from here, I'm going to keep track of all of my squares. I have 3, negative 8, positive 6. So if I add all these together, I have 3 minus 8, that's negative 5x plus 6. So in other words, I can do it on a calculator too to make it easier. Let me close my geometry, close this. There we go. So I have 3 minus 8 plus 6. I get 1. So this becomes x squared. Then I'm going to keep track of all of my x's. All right. So 9, negative 3, 12, negative 14. So 9 minus 3 plus 12 minus 14. I'm going to get 4x. So this becomes plus 4x. Now doing my constants. 6 minus 10 minus 28. 6 minus 10 minus 28. Negative 32. So minus 32. Did I do something wrong? 6 minus 10. Did I forget something? Where did they get 17 from? 2, 2, 2, 2. I must have forgotten a 10 somewhere. $12. What happened here? Okay, so we did this. So this was what we got from the box method, which is right. And then I must have done something wrong here. 3, that's the x. 6. Oh, this is a positive 10. This negative turns this into a positive 10. Does that make sense what I did wrong there, guys? So always pay attention to that. You distribute the negative sign. Thank you. I should have looked at the chat earlier. Thank you for that. Yes, she's right. I missed the 10 there. So that's what made that go completely wrong. Thank you for that. So make sure you're paying attention to these negatives and positives because as you saw, it can totally change your number if you distribute these incorrectly. All right. So looking at the next stuff, does that one make sense, guys? Besides the fact that I messed up in forgetting to distribute? Cool. All right. Now this one over here. So I showed you guys how to multiply. I'm going to show you how they came up with this number right here. Let's say I'm going to do this wrong on purpose to show you guys how you're supposed to do this box method. So x squared minus 12, and we're going to leave this 4x here. The reason why we leave the 4x here is we don't know where it goes because it has to be this plus this gives us 4x. So when we do this, we know it's going to be x times x. Now I have to make this negative 12. Again, I told you I'm going to do this wrong on purpose. So let's say I'm going to be like, okay, well, I want a positive 4, so I'm going to put 4 here, and I'm going to put a negative 3 here. That gives me negative 12. This should work. But then when I do this, I get 4x, negative 3x. Like, wait a minute. These two give me only 1x. So I messed up somewhere. So what I'm going to do here is I'm just going to erase the parts where I think I messed up. And I'm going to change this to, well, let me try another way for me to get 12 is 6 times negative 2. That gives me 6x here, 6 times x, and this here makes it negative 2x. That's going to give us a 4x. So that way it makes way more sense. So in other words, I get this x plus 6 times x minus 2. That's how they got this answer right here. In other words, this is the same thing as this. This area is the same thing as this. So lengths equal, or area equals length times width. You guys have probably done this in geometry or somewhere in elementary school, length times width. That's why this is the same thing as this. We're doing the lengths, x plus 6 times x minus 2. If we put these all together, x squared plus 6x minus 2x minus 12, we would get x squared plus 4x, combining these two, minus 12. So the box method is something I'm really going to focus a lot on when we're doing this. Remember in that last one, the last lesson, they were talking about factoring by grouping, and I said that's not the best way to learn it. I'm going to do box method a lot. So next we're going to learn about the words. So an exponent is this little power symbol right here. Variable, constant. Constant means it has no variable. Coefficient, when I say coefficient, I'm talking about the number in front of the variable. So these are words that I'll be throwing around a lot. So it's a good thing to either have these written down somewhere or just, if you guys ever hear me say a word, even if you don't know how to spell it, like if I say the word coefficient and you guys don't know what that means, just type in the chat to say like, what's a coefficient? And I'll emphasize it more. The next thing we're going to do here is they're going to be talking about standard form. These numbers right here, these a sub n, and that a sub n is just talking about a sub n. Give me a second. A sub n. That just means a, and it has a subscript of that to the power of n. So all this is saying is the coefficient. Let me get my laser out. Where's my little laser? There it is. So what this is saying here is the coefficient that goes along with this variable and its exponent. So we're always going to write this with the highest power first. That's all this is saying. We do the highest power first, and then we do the one with 0, and then we do our constant at the end. That's all this is saying. It just says it with weird letters because we don't know up to what power we're going to. By the way, I'm not sure if they've talked about this yet, but this highest power is called a degree. So the degree is known as the highest power. All right. So when we're doing this, a cubic has a highest power of 3, a quadric has a power of 4, a quintric has a power of 5. Honestly, other than cubic and quadratic, when we talk about this, I would just say like degree 4, degree 5. But the way we identify polynomials is by their degree and how many terms they have. So this has 3 terms. This is a term, this is a term, this is a term. So they're basically separated by these plus and minuses. This is a 3 term, so it's called a trinomial. That means 3 numbers. This is its own number, this is its own number, this is its own number. This is a monomial, 1 term. Binomial, 2 terms. This vocabulary is going to be on the mastery test as well as the post test, I think. So make sure you're understanding how to identify the terms and the degrees. So those degrees, and then right here, again, you can always click these to get an idea of how to describe them. This is degree 2 because the highest power is 2. Monomial, 1 term. Binomial, trinomial. Edmentum has all the tools. If you guys need to review it, again, feel free to review it or make an appointment with me. All right, so let's get into this. So using the degree, what's the highest power here? The highest power is 3, so we call that a cubic. Oh, they use these terms. Don't stress too much on knowing this. You literally only have to know this for, I think, this module, and that's it. Afterwards, we're going to talk about degree 5, all those other stuff. So here, you don't just say it's a constant because there's a degree 5 here. So degree 5 is a quintric. Degree 4 is a quadric. I really hate these names. They're not really used that often. So bear with us, guys. If the highest power is 1, that's called a linear function. The reason for that is this reminds us of y equals mx plus b. That's all we're talking about here. Whenever we have a squared, the way to remember squared is this idea of quad. Quad means a square. So this is a quadratic. How many terms is this? This is 1 term, so it's a monomial. This is 2 terms. This term and this term. So this is a binomial. 1 term, 1 thing altogether, monomial. 1, 2, 3 terms, trinomial. 2 terms, binomial. Is it making sense, guys, how to describe these when it comes to describing it by the degree and describing it by the terms? Yes, no, maybe. You guys asleep on me? Cool. All right. So now we're going to be describing these. So numeric expressions. So numeric expressions are just how we add and subtract. Algebraic expressions usually have these variables. It means we don't know what these are yet. We're going to figure them out. We just don't know what our dependent variable is to figure out what we're going to get out of it. Sometimes we have to distribute and we're going to have to combine the terms. So I'll try to use colors like they do. The colors usually help in helping us identify them. So they're going to distribute the plus sign, and then they're going to organize them, then they're going to add them together. So remember, in order for them to be like terms, they do have to have the same variable and exponent. They both have to be the same. If we're distributing a negative, just remember we're distributing it to all of them. Who was it? One of you, I believe. Forgive me if I pronounced your name wrong. Jocelyn. Um, as Jocelyn pointed out, I didn't distribute my negative to make it a positive 10. So make sure when you're distributing it, you distribute that negative sign to all of them. All right, so what we're doing here is now we're going to multiply all of these together. So the way they do this here is this idea of, hey, this one has less terms, so what we're going to do is we're going to distribute this to these. Another way of thinking about this is doing it the box method way. So you always want your rows to be the least amount. Give me a second here. Your columns should be whatever it has the most of. So here I'm going to do 4x squared, or let me copy their colors. 4x squared, and their other color, I'll just make it black since they don't have a color. -1. I'm going to erase this, make it blue to stand out more. And then on top, this yellow, I'm going to put the 7x squared, 6x, and this 2. So when I do this, I'm going to multiply out. So this is the same thing as what I'm going to get over here. I don't know why they didn't highlight it. They should have. So if I keep up with their highlighting, this is there, 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 and then they do it again. So that's what's happening here. They're essentially doing the box method. They're just writing it out a little bit more. Then they're going to simplify it. The thing with the box method that's cool is what's going to happen is usually you can just add these two diagonals sometimes. If not, you can just write it out. So that's two ways of doing it. They're doing it by the FOIL method, first outer inner last. I like the box method better because it's going to help us figure out how to factor later. All right, so now let's get into an activity. So when we're doing this, again, I don't recommend you guys doing the activity. I recommend you guys taking notes while we're doing this. It just makes it a little easier to go back and visit this later. So what we're going to do here is we're going to distribute the plus sign, which doesn't really change anything. Doesn't change anything at all. So I'm going to add these two together. And that's going to give me this 4x to the 4th. And when you're writing these down, guys, please use the... Oh, it's already in equation editor mode. I'm so used to having to click that equation editor that I forget. Sometimes they do it. Put your terms together. So do this x power 4. It's just easier to kind of do it than keeping it all in your head. All right, so we have that. So I'm combining those. Then I'm going to do any power 3s. I don't have any power 3s. But while I was looking for a power 3, I noticed there was a power 7. So I'm going to do this power 7. I don't see any power 3s. I do see a power 2. So I'm going to bring that power 2 over here. 2. Now I'm going to do power 1s, which is minus 9x. Now I'm going to do another power 1, which is at 5x. And any constants, which is this negative 10. From here, what I'm going to do is I'm going to combine my like terms, so these two, and oops, I did a power x. How come you guys didn't tell me about this power x? There we go, power 2. All right. And I'm also going to combine these two, and I'm going to show that in my next step. So one thing that I don't like about Admentum is it tells you you're doing it wrong when you're showing your work. When you're doing your unit activities, though, guys, I do want you guys to show your work. I want you guys to do it the way I'm doing it here. That shows me that you guys are learning it, and if you guys aren't learning it, we can always work on it together instead of just like, well, I guess they got it wrong. All right. Up to, is this making sense so far, everyone? Then this would be minus 4x and a minus 10. So this would be how we finish it off. So make sure you're showing your work here, submit it. Again, it says incorrect. I really hate that it says incorrect. I really do. I don't care if it says incorrect. I really like that it shows the work. They want you to literally just type out the answer only. Not the biggest fan of that. So unfortunately for tutorials, it does only want the answer. For activities, I do want you to show your work. I want you to show this part right here. Show you guys distributing the negative. Which is going to give you these numbers right here after you distribute the negative. And then I want you, you don't have to organize, to be honest. I could do without this step, but I at least want to see the distributing. The organizing, you guys could circle it in your head, circle it in your notes. That's perfectly fine. Oh, let me go to answered. Here, if you get to this point, this is a lot of work to show here. What I want you guys to do when it comes to an activity, do a box method of it. If you box method it, it's a lot more organized, number one. And when you box method it, let me show you how to kind of keep organized. Oops. Make sure all the powers are already organized. You always want to do the highest power first, the next highest power second, and the last power at the end. This will just make it easier for you guys to organize everything when you're writing it down. So from here, if I were to finish this box, let me finish it real quick. 8, 6, negative 88, y5, negative 6, y3, positive 66, y2, because the negative and the negative make a positive, negative 5y squared, and positive 55y. If I were to write this down and compare it to here, it's essentially the same thing, except mine's is already organized a little bit more. I can go boom, 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 boom. These two are going to combine because they have the same power, which is, you can see it right here, combines together to make that. So honestly, I recommend doing this. This is easier to take a picture of. You don't have to show all this work. You write it all down and write your answer down. It's the easiest way to show your work when doing these. This one, what we're going to have to do is, do you guys want me to do another box method to show you guys how to do this one, or you think you guys are good? One more to show the work, or what do you guys think? You're good? Everybody else good on it? Let me know in the chat. One more? Cool. No problem. So this one is a little trickier. So we're going to have to distribute this negative later. So what we're going to do here is first I do a box. It is a 2 by 2 box, 2 by 2. The smallest number should be whatever's on this side right here. The biggest number should be on top. So this one doesn't really matter. So what I'm going to do here is I'm just going to put my 3x squared here. Do not put this x in yet. That comes later. I do that. I do my plus 1 here. Let me erase this so you guys don't get confused. So that's my x squared plus 1. I'm going to put this in order. So I'm going to put negative 8x here and a plus 4 here. So when I do this, I'm going to get this negative 6x cubed because it's a squared times an x, so it's a cube. This becomes 1 times negative 2x. I'm going to try to remember to move my mouse because if I move my pen, you guys don't see it moving, but if I move my mouse, you guys see the pen moving. So I'll try to remember that. So this is negative 2x. I'm going to multiply the 3x squared times the 4, so I get this 12x squared, and then this is 4. So if I wanted to see this negative 6x cubed plus 12x squared minus 2x plus 4, I'm going to bring back this parentheses. I said don't do it yet. If I wanted to see this part, it would be on the right side here where these two multiplied. So that would be right here. Wait, what's going on here? Oh, this is an 8. I am so sorry, guys. This is an 8. I can't even read my own writing. I'm so sorry. So that's an 8. So these are all wrong. That's an 8x. So this is going to be 8 times 2 is 16. 8 times 3 is 16 plus 24. X cubed. And this is going to be negative 8x. So this is 24 negative 8x. If I wanted to see this, I would see it over here. Negative 24x cubed, 12x squared, the 12x squared. That's what's here. Did that help out doing that extra box method? Yes, no, maybe? Is the box method making a little more sense, guys? Are you guys awake? Hello? Cool. All right, cool. All right. From there, then we would distribute this negative. So we would distribute the negative. I like keeping mine in order. Edmentum, I don't know what's up with Edmentum. They don't like keeping it in order, but then they're like, oh, but we want our answer in order. We don't care about how you do your work, but we do want your answer exactly the way we want it. So it's a good habit to put it in the correct order. That way, when you're doing it, you know, oh, highest power always goes first. This is bugging me. There we go. So that's how we would do the box method. Then we would combine our terms the same way we normally would. So the difference here is this, you always have to do your multiplication first. So you're going to have to do your box method first, then distribute your negative, and then you can combine your like terms. Let's give this a second. Oh my gosh. While this is loading, I know it says geometry, I just haven't changed the name yet. You guys can answer the questions to get credit for attendance. You can state your nickname, the best teacher you've ever had, or 3 people you would want to party with. In the chat. If you haven't talked in the chat yet, that's how I keep the attendance. And this just lets me get to know you guys. Let's see if this page loaded. Oh my gosh, why is this not loading? Sorry for all the technical difficulty, guys. I don't know why I keep doing that. So one of these properties is talks about closure. The closure property just says that if we do an operation, it should give us the same thing. So for example, integers are closure. If we add integers together, we get an integer. Polynomials are the same thing. If we add polynomials together, we would get another polynomial. It'll just look a little different. That's what it means by closure. So, so that's what it's talking about here. If you multiply, add, or divide, multiply, add, subtract, it's closure. You still get an integer. Polynomials are the same way. They're still closed under the same exact operations. So we're going to verify by closure. So here. So if we do this 202, this is what we're talking about. This is a set of numbers. If we add these two together, so 2 plus 5, we get 7. 7 is not in our terms here. So that means this is not closed. If we're talking about this is not closed under addition. If we add 2 plus 5, we don't get a 0, 2, or 5. So this is not closed. If we're talking about integers, all integers closed under addition. So if I add negative 20 and 6, is negative 14 an integer? Now we're talking about integers. We're not just talking about these 3 numbers. These 3 numbers aren't closed. If I add them together, they won't get the 3 numbers. But integers, yeah, these are closed. So it is included. Negative 14 is included, so that means it is closed. The set of polynomials under addition, so if we're doing this plus this, we get this. So this would be closed, and it is included. So is this a polynomial? Yes, it is. So when we add them together, it's closed. Wow, that's an interesting party. I would totally be into that party. Nelson, for your question. Anyway, is this making sense though for closure? Closure is basically just saying if we do multiplication, or if we're saying is it closed under addition? That means if we add them, do we get something that we said was in that group? If we multiply them, do we get something that's in that group? That's what closure means. So if it's included, that means it would be in the set. 7 is not included in this set, so it is not closed. So, for example, let's say we have this. We are going to do this multiplication and addition. So what this is saying here is we're going to add this plus this. We're going to add this a plus this b. So 5x minus a plus 2x. Okay, so we're going to have to add these and this. So we get this 7x minus 1. So that's 7x minus 1. That is a polynomial. So far we're proving that it's closed so far. Let's do subtraction. So if we subtract, we get 5x minus 1 minus 2x. So if we subtract, we get 3x minus 1. So we get 3x minus 1. This is still a polynomial. It didn't become like not a polynomial. Next thing it wants us to do is it wants us to multiply. So I'm going to do this and this, 5x minus 1. I know I'm really pushing this on you guys. You guys can distribute if you want to distribute. That's fine. I like this. The only problem with doing it this way is you kind of have to take a picture. So if we do this, our answer is going to be 10x to the power of 2, which they already wrote here because they're like, we don't want them typing in power of 2. So then we do minus 2x. All right, and blah, blah, blah is correct. So are these closed? Is it closed under these three operations, under addition, multiplication, and subtraction? Yes, it is. So we would write blank is correct. Complete the statements and then determine who is correct. Oh, okay. So they disagree on subtraction, addition, multiplication. To examine the two positions, blah, blah, blah. So who's saying what? I don't know who's saying it is closed and who's saying it isn't. About whether, if you guys see it, oh, Marina thinks they're closed. So Marina's right because they are closed. I still get a polynomial. I'm still getting a polynomial, so they're closed. If I got something weird that was not a polynomial, then I would say that the other who's the other person? Bethany would be correct. All right. What are they closed under? They do not have division. The only reason they don't have division is I actually don't understand why they don't have division. But they don't. I think they want to say that they don't have division because this would technically not be a polynomial. Doing 3 divided by x plus 3 would not be a polynomial. Does that make sense? This isn't a polynomial because polynomials are a coefficient, a variable, and an exponent. This one is like, well, what's the coefficient? The variable's here. The exponent is where? So it would look something like this if we kind of tried to make it that. Does it kind of make sense why division doesn't work for closure? Anybody? It's okay if it doesn't. I just want to get an idea. Does it make sense why we can't divide and still get a polynomial? Hello? Are you guys there? Kinda? Yes. The main idea is this whole idea that, for example, 2x is a polynomial. X plus 1 is a polynomial. But if I divide this, I can't simplify this to be a polynomial. I'm kind of stuck like this. If I'm dividing is the same. Fractions are the same thing as division. this isn't a polynomial. So that's how come it's not closed. It's closed under addition, it's closed under subtraction, it is closed under multiplication, but division doesn't. So if you guys are having trouble understanding why division doesn't work, you can always write right here that you're having trouble understanding that part. Let me get this through. So we're going to get through this one. So this, we're going to talk about the definition of a polynomial. Polynomial, two expressions whose quotient simplified into this. Division problem, whose polynomials closed under division, describe how operations are different from division. Okay, so this technically is a polynomial. This 1 over x is a polynomial. It's x minus 1, right? So I would say the reason division is different from addition, subtraction, and multiplication is when we divide by more than one term. It can not be simplified into one term. So that's the idea of what I got over here when I said something like 3x plus 2 divided by x plus 2. You can't simplify this always. You cannot. Let me phrase this better. You can't always simplify into one term. Sometimes you're stuck like this. So that's why it's different. When you're multiplying, you can simplify it into individual terms. My bad. Individual. What I mean by individual terms is you'll get this fraction. So sometimes you get a weird fraction. All right. So unfortunately, this lesson went on a lot longer than I wanted it to. The other half will be a video in the Google Classroom. Yes, Jocelyn, I understand. The rest will be a video in the classroom. Nelson, did you understand a little bit more now that I described it better?